All right, everybody, good morning. It is April 14th, about 10:30, and we're getting started going over the practice exams that I gave you guys to do over spring break. And Tyler Lentz is asking to do number 5 on practice test 3. Let's check that out. Okay, it says, let h of x equal ln of the absolute value of g of x. If g is decreasing for all x in its domain, then what? And this says A, h is strictly increasing, B, h is strictly decreasing, C, h has no relative extrema, D is both B and C, and E is none of the above. Okay, so G is only increasing, right? So this guy right here, G of x, oh no, it's decreasing. G of x is only decreasing, so this guy is decreasing. Okay, and then we're taking the natural log, so h of x equals a natural log of the absolute value of a decreasing function. Well, if something is only decreasing, right, let's say that, here, how about I do this? So if g of x, let's say, is only decreasing, it might be positive and then go to negative, right? So what would the absolute value of something that is decreasing, what would that look like? It wouldn't only be increasing, right? It would still be decreasing as long as what is decreasing is positive. But what it would do is it would take this portion and it would bring it up here. So this absolute value of the decreasing would turn it into something that is decreasing, and then it would bounce off. And if it continued to decrease down there, it would really put it up there, right? So this is what is inside of the natural log. Someone's trying to join. Right. So this is what I have. The fact that G is decreasing, you know, I would then flip it up like that. So let's look at it. If I have the natural log of this thing now, so this is inside the natural log, right? So, and h of x is the natural log of the absolute value of that thing. So it's the natural log of this V-shaped thing. And it doesn't have to be a V. I'm just making, hold on one sec. My kids are, I need to yell at them real quick. Sorry about that. Okay, so, so if I have something like this, is h strictly increasing? Well, no, because for these values, if I take natural log of something that's getting smaller, then h is decreasing, and then h is increasing. So h is not strictly increasing. Is h strictly decreasing? Well, no, because as g decreases, right, and it's getting further and further down over here, I would see that this is getting greater and greater, and so the natural log of the absolute value of that part would be increasing. So I would, h is not strictly decreasing. H has no, so we know that both B and C is not correct either. So it's got to be either C or none. So C says H has no relative extrema. Okay, let's talk about this right here. That right there, where g of x is equal to 0, that's where g of x changes from positive to negative, right? But what is ln of something that is approaching 0? What is ln of 0? Well, it doesn't exist, right? ln of 0 approaches negative infinity. And so, oh, sorry, someone's waiting. And so if we have that as g of x is positive and then goes to 0 and then would be, g of x is negative, but then the absolute value of that turns it into a positive. Right here, g of x is equal to 0. And at that point, the natural log of 0 doesn't exist. That goes to one of the infinities. So when we look at h has no relative extrema, one thing that we could do is for h of x, talking about relative extrema, is we could look at the derivative. So h prime of x is equal to, what's the derivative of ln of anything? It's 1 over that anything times that anything prime and that would also be absolute value like that. Yeah, it's looking like the only point that would be on or a consideration for relative extrema is when g of x is equal to 0, but when g of x is equal to 0, ln is not going to exist. So I'm pretty sure the answer is going to be E on this. I don't know if I'm right. You guys already... no, let's see. I need to get to my... So that's number 5. Let's see what they have. So they have C. So let's check this out. So it says h prime of x is equal to, I can't really see that. Let me zoom in. H prime of x is equal to g prime of x over g of x. In order for h to have any relative extrema, its derivative, h prime, would have to equal 0 at some point. Since g is always decreasing, g prime is never 0. And since g prime is the numerator of h prime is never 0. Therefore, h has no relative extrema. Oh, was that a, I thought it said had, hold on, let's go back to this. Oh, has no relative, I'm sorry. Yeah, h has no relative extrema. So I think that's what I said, but then I said E, but h has no relative extrema, which would be C. Because the only point where h would have a relative extrema would be right here, but then h doesn't even exist there, right? And so the answer is going to be C, no relative extrema. Did that make sense? Yeah, the other way how they have it is if you're looking at this, g prime over g of x, well, g prime is never 0. In order for h prime, or for h to have a local max or min, h prime either has to equal 0 or not exist. H prime is never equal to 0 because g prime is never equal to 0 because g is decreasing, so g prime is always negative. And then g always exists because we're only talking about in its domain. So the x value is in its domains, meaning that it will always exist. So that's another way that you could look at it. Okay, next was 28. Tyler Barton, is that number 28 on exam 3? This always goes away. Yeah, 3. Okay. So here we go. Okay, so this is number 28. It looks like a, so we have a Taylor series problem. So let's check it out. It says, I'm gonna move this somewhere. Move that up there. It says, so we have the summation as n goes from 0 to infinity of a sub n times quantity x minus c to the n. It's a Taylor series that converges for x, to f of x for every real x. Then f double prime of c is equal to what? So f double prime of c. Well, this guy is equal to a naught plus a sub 1 times x minus c to the first plus a sub 2 times x minus c squared plus a sub 3 times x minus c, c cubed plus dot, 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 right? This is f of x is equal to that. So if you remember, you know, we said, okay, if f prime of x is equal to, well, that would be a sub 1 plus 2 a sub 2 times x minus c plus 3 a sub 3 times x minus c squared plus dot, dot, dot. And we said that f prime of c is equal to, well, when you plug c in, all of these guys just go to 0, and it's just equal to a sub 1. And then we said f double prime of x is equal to, so this was 2a sub 2 plus 3 times 2 times a sub 3 times x minus c plus dot, dot, dot. So f double prime of c is going to be equal to this 2 times a sub 2, right? 2 times a sub 2. That is a double prime, right? It looks like that's kind of tough to tell. But anyway, so that should be just 2 times 1 times a sub 2. So it looks like b. I don't like how they put n in there. If they tell you what n is 2. But anyway, that's, I believe that's going to be b. Let's see what they have. Number 28. Where are we? It says f double prime of x is equal to n minus 1 times n times a sub n times x minus c to the n minus 2 is equal to 0. Did they have it as a second derivative there? Yeah, I don't like what they have going on here. Anyone else want to chime in on what they have here? Because they're asking for, let's go back to what I have here. So this is the Taylor series. That Taylor series for F is going to look like this, right? So we have that's going to look like this all the way through. This is obviously centered at C. So F of C is just going to be A sub 0. F prime of C is just going to be A sub 1. And F double prime of C should be 2 times A sub 2. And again, we know, right, in general, so let's just say in general, this is what we know. In general, A sub n is equal to the nth derivative of F evaluated at C over n factorial, right? We know that this is true, which again, if you wanted to solve it only for the second derivative of F at C, this also, tells us that F, well, let's start with just the general. The nth derivative of F at C is equal to, let me move all this over. Is equal to n factorial times A sub n, right? So really here we have the second derivative of F at C should be 2 factorial times A sub 2, which is just 2A sub 2 is correct for that. You guys talk to me. What do you think? Because in their answer, they have that F double prime of X is equal to this. It'd be a lot more than that. F double prime of X is equal to what I had there. It goes on a lot more. It's 2A sub 2 plus 3 factorial times A sub 3 times X minus C plus 4 factorial times A sub 4 times X minus C squared plus all the way through. So I would say the answer should be 2A sub 2. Anyone else want to comment on that? I have 27 of you here.
I see what you did and how you got the 2A sub 2, but then also it's like the book, they took the derivative of like the general term, and then like when you do that, it looks like you get 0 because it's like C minus C is 0. I don't really get why they're different. Or
right, but taking the derivative of just the general term. So the thing is this, right? For Taylor series, we have that the nth coefficient, right? The nth coefficient is always the nth derivative of F evaluated at C over n factorial, right? There are constant terms there. So when you plug in C for X, all of the other terms other than the constant terms are going to cancel. But the constant term is still there. That's why f prime of c is not 0, it's a sub 1. And why the f double prime of c is 2a sub 2. And in general, why the nth derivative of f evaluated at c is n factorial times a sub n. I mean, we worked that out before, right? And you could get that by doing this, expanding out what the series notation or summation notation has. You don't just take the derivative of the inside term. I'm thinking really quickly of another way. Yeah, I mean, I think
Well, I think I get it now, because like if you were to expand out the f double prime of c with the summation, when you go from n equals 0, then the whole thing's 0 because there's no first term. Then the n equals 1, it still cancels out. And then n equals 2, it's c minus c to the 0th power, so that just comes 1, and then times, or I don't, did they just do it wrong? And then now they're confusing us.
well, no, I think the way that they approach, so the way that here it is. The way that we're looking at this is the fact that they tell us that this is a Taylor series that converges to f of x. I would say that f of x is equal to that, right? And so when we look at the general, form of a Taylor series, what we have is that, we would say that this is equal to the nth derivative of f evaluated at c over n factorial, right? That's what they're telling us. You go back to what I did, when I was first teaching this. That's what the Taylor series gives us, is that there is a pattern for those coefficients. And that pattern is, it's the nth derivative of f evaluated at c over n factorial. So that's what we have going on there. I think what they're doing is this. I think this is what he's doing is, if f of x equals a summation as n goes from 0 to infinity of a sub n times x minus c to the n, then he's saying, okay, well, f prime of x is equal to the summation as n goes from 0 to infinity of, bring down the n, so it's n times a sub n times x minus c to the n minus first. And then f double prime of x is equal to the summation as n goes from 0 to infinity of n times n minus 1 times a sub n times x minus c to the n minus 2, right? But then n actually would start at 1 here, and n would have to start at 2 there. So that we would have a power series. Otherwise, you'd have a negative, negative power. So that'd be 2 times 1 times a sub 2 times x minus c to the 0th power. Which is 1. But he's plugging in c in for that x here and saying, oh, 0 minus, or c minus c is 0 anyway, so that's going to be 0. But that's not, that's not true. So 28, I would say my answer for 28, the second derivative of f evaluated at c is going to be this, 2 times a sub 2. That's what I would put on here. 2 times a sub 2. Now, this is not, now if you're saying, well, what about the AP exam? Well, first of all, there's not going to be any multiple choices on the multiple choice questions on this year's AP exam. And number 2, it wouldn't be, the answer would be 2 times a sub 2. I'm telling you. So, yeah, I hope that cleared it up. It was basically, if you're looking at 28, that was a bad problem that was on there on this practice exam. Okay, what else do we have? Tyler Barton, I just see that you said something. If you do the first derivative and plug in C, doesn't it start at 0 when you plug in terms? I think I explained that going through. Okay, next we had do number 16 on practice test 3. Number 16, let's check that out. Here we go. Okay, so we have this guy going on right here. And okay, when we have an integral, right, we talk about the techniques of integration. So maybe the first thing that we would think about is doing a u substitution. Well, setting u equal to 3x is what's inside another function. That might help us a little bit, but really what this looks like is we have a monomial multiplied by an exponential. What first comes to your mind when we have something like this for like a polynomial or a monomial multiplied by an exponential? What did we do? What technique did we do? Integration by parts is correct. That's what I think of as well. So let's kind of dive into integration by parts. So we would set u equal to the thing that we want to differentiate and make easier. So that's going to be 6. Actually, what I would do is I'd bring this 6 out in front. So I'd say that this is 6 times the integral of x cubed times e to the 3x dx. And then I just will multiply by that 6 at the end. So I'm just going to say that u is equal to x cubed and dv is e to the 3x dx. So that du equals 3x squared dx and v equals 1/3 e to the 3x. So I would have that this integral right there. Shoot, what just happened? Sorry, guys. So that integral right there is equal to, so let me bring that all the way down here. uv, which looking at this guy, that's going to be x cubed times 1/3 e to the 3x. So that's going to be 1/3 x cubed e to the 3x minus the integral of v du. So v du, the 1/3 and the 3 cancel out, and I'm left with x squared e to the 3x dx. Right? So now I would say, well, this integral, I'm going to do another integration by parts, where u equals x squared, dv equals e to the 3x dx. So v is again going to be 1/3 e to the 3x, and du equals 2x dx. And so this integral becomes uv minus the integral of v du. So again, I have my 2 and my 1/3, so I'm going to bring out the 2/3 right there. And now I have this integral. So guess what I need to do? Do it again, integration by parts, which this kind of stinks. And there is a trick to doing integration by parts multiple times. But it's easier just to do it again. So here we go. U equals x and dv equals e to the 3x dx. So v equals 1/3 e to the 3x and du equals dx. So now this ends up being uv minus the integral of v du. I need more space here. uv minus the integral of v du. So v is 1/3, and that's just e to the 3x dx. So this ends up being 1/3 x e to the 3x minus 1/9 e to the 3x. I'm going to have my plus c that's going to be in there. But this right there is just what was inside right there. So let's go back up. In blue, I would have, this would be 1/3 x squared e to the 3x minus 2/3 times that, which is 1/3 x e to the 3x, and then minus 1/9 e to the 3x. And then this has a plus c in there. But this, going back up, and I know this is a pain in the butt because you have a bunch of these. What I have right here is what that is, right? Oh, no, sorry, that goes right there. So in red, I would have that it's going to be 1/3 x cubed e to the 3x minus, and then this whole thing, which is going to be quantity, 1/3 x squared e to the 3x minus, do we distribute through here? Let's do it. Minus 2/9 x e to the 3x, and then that's going to be plus, what is that, 2/27, and that's going to be e to the 3x, and then we have a plus c there. And now this whole thing is going to go up where that is, right? So I now need to multiply everything that was down there by 6. So if I were to take this whole thing and multiply by 6, then that ends up being, let me see if I could do this. So that's I'll do it right here. So that's going to be 2x cubed e to the 3x. And then minus, what is that? 2x squared e to the 3x. And then that's going to be minus, no, that's, it's going to be plus because you're going to distribute through by that. So plus, so it's 3, so 2, 4 thirds. And that's going to be x e to the 3x. And then that's going to be minus, because you're going to distribute through that negative to that guy. So minus 5 by 3, so that's 2, that's 9. So 4/9 e to the 3x. And don't forget your plus c. So this is my answer. But looking at what they have, oh, and then you could factor out an e to the 3x. So when you factor out an e to the 3x, this is messy, but that's going to be, let's see, I'll go up right there. E to the 3x times, so that's 2x cubed minus 2x squared plus 4/3 x minus 4/9, and then that's going to be plus c. Okay, so I kind of fit it in there because I wanted some space. So looking at this, everything inside here matches inside there, but they have a 2/9 there, so that can't be right. So I'm looking at factoring out a 2/9 because these last three have factored out a 2/9 also. So if I factor out a 2/9 from that, 2/9, that's me multiplying every term inside by 9/2. So by 9/2, this becomes a 9. That becomes a 9. By 9 over 2, 9. What is that? 4/3 times 9/2. So that's 6. And then negative 4/9 times 9/2 is just negative 2. So I have, man, this is ugly. 2/9 e to the 3x times, and that was 9x cubed minus 9x squared plus 6x minus 2, and then plus c. So there we go. And that is that E? Yeah, it looks like E. Man, that was a mess. I think that's probably my messiest problem I've ever done in front of students. Way to go. Anyway, were you guys able to follow that? Kind of? Anybody? Sorry, it was so all over the place. It was just a ridiculously long problem. Again, there would never be a problem on the AP exam where you would have to use integration by parts, however many times I just used it, which was one time to go from blue to red, another time to go from red to blue, another time to go from blue to green, and then you got to backtrack. Oh, that's there, so now it's in blue. That's there, so now it's in red. That's there, so now it's in black. And then you had to simplify it so that you could get it in the correct form that they have the answer in, which ended up being E. Anyway, that's what we got going on. Okay, what else? Anything else that you guys want to see from the exams 3 and 4, the practice exams that I gave you guys? Fourteen. Let's check it out. Okay. Here, let's cut this and go to another page. Okay, here we go. It says, let f be defined as this piecewise defined function where f of x is equal to the cubed root of x plus k times x when x is less than 1, and f of x is equal to ln of x when x is greater than or equal to 1 for some constant k. For what value of k will f be differentiable over its whole domain? Well, we already know that when x is less than 1, f of x just looks like this. That's always going to be differentiable for x less than 1. For x greater than 1, if we take ln of x, f of x is always differentiable. ln of x is always differentiable as long as x is, at least greater than or equal to 0. But in this case, they say greater than or equal to 1, so it will be differentiable there. The only thing we have to determine is find the k value that will make it so that f prime of x is going to be the same as you approach 1 from the left and from the right. So again, let me write that down. So the trick here is to look at, if we take the limit as x approaches 1 from the left of f prime of x, this must equal the limit as x approaches 1 from the right of f prime of x. Because we've already determined that everywhere except for x equals 1, this thing will be differentiable. So what value of k would make this differentiable for all values of x, namely at x equals 1, because it's going to be differentiable everywhere else. So here's what we're going to do. So here, as we take the limit as x approaches 1 from the left, f prime of x is what? What is f prime of x there, y'all? Anybody. You can unmute yourself. You can type it in. What is f prime of x if x is approaching 1 from the left? Meaning if if x is less than 1. So you would take the derivative of this part of it, right? This is what the function is equal to when x is less than 1. So what's the derivative of this part? Treating k as a constant. What's the derivative of that? Well, this is x to the 1/3, so that would be 1/3 x to the negative 2/3 plus k. And this must equal the limit as x approaches 1 from the right of f prime of x. So what is that equal to? What's f prime of x as I take the limit as x approaches 1 from the right? That's just the derivative of ln of x, which is what?
1 over x.
Yes! Okay. So now when I have this, I can see on the right-hand side of my equation here, the limit as x approaches 1 of 1 over x is just going to be 1. Everyone sees that, right? And then over on the left-hand side of my equation, as I approach 1 from the left, 1 from the left, I have that x to the negative 2/3, that's 1 to the negative 2, that's just going to be 1 times 1/3. So this is going to be 1/3 plus k. Right? So solve for k. So k must be 2/3. Did that make sense? Let me see what they have for this guy, because they've been doing some kind of weird things. It's number 14. Ooh, nice, nice. Okay, I spoke too soon. I spoke too soon. In order for f to be differentiable, two things have to be true, right? It has to be continuous, because you think about, okay, for what, when is a function not differentiable? There are three things that make a function not differentiable. Number one, if the function is not continuous at that value. Number two, if the there's a corner or a cusp or something like that, that's where the derivative changes instantaneously. So we need the left hand and right hand limits of f prime of x to be the same. And 3 is a vertical tangent. Well, here, what we just found is that the only value of k that would make the derivative be the same from the left and from the right is when k is equal to 2/3. What I didn't do then was to verify that the function is continuous there, because that needs to be true. So then when I plug in 2/3, I have, so now we look at the limit as x approaches 2/3 from the left of f of x, and we're saying, is that equal to the limit sorry, not x, I'm saying, sorry, as x approaches 1 from the, as x approaches 1 from the left of that, is this equal to the limit as x approaches 1 from the right of f of x, with k being what we just found it to be 2/3. K is now 2/3. Okay, so let's check this out. So here we have the limit as x approaches 1 from the left of f of x is going to be so I guess that'd be cubed root of x plus 2/3 x, which is just equal to 1 plus 2/3, so 1 and 2/3. And then I'm going to look at this part. The limit as x approaches 1 from the right of ln of x is equal to ln of 1, which is 0. These guys are not the same, which means that the function will not be continuous. And so if the function is not continuous, then the function will not be differentiable. So k equals c, or sorry, k equals 2/3, which is what they have for c, will make the derivatives be the same. However, the function is not continuous. So here's what it's actually going to look like. You ready for this? It's going to look like this. So as we get close to 1, we have that the left-hand limit so it's going to look like this. This guy is going to look like that, right? Because that's what the natural log would look like. But then this other guy looks like cubed root of x plus 2/3. So it's going to look like, what did I put? So this slope of the tangent line there and whatever the slope of the tangent line there is going to be exactly the same. But then this looks something like that. Okay, so the slopes of the tangent lines would meet up so that if I were able to raise this up right there, then the tangent lines would make it a nice smooth curve. However, the function is not even continuous because there's a jump discontinuity there. So that's what we got going on there. So for this, it would be 2/3. However, at 2/3, the function is discontinuous. So where will it be differentiable? None. In fact, never. Okay. That's what we got going on. All right. What else do we have? Problem number 2. Let's check out problem number 2. I'm actually going to say this, Kayla, now that I'm looking at it. This is a parametric problem. Let's not even talk about that. That's one of the things that is not on the AP exam for this year. Maybe after I'm done with this, if you still really want to see that, we'll do it. But I'll put this over here. But yeah, let's focus on. I'd rather spend our time on things that are going to be tested for this year. So let's hold off on that. Anything else from the practice exams before we kind of dive into some of the free response questions that I want you to focus on for the next couple days? No. Okay, cool. So here's what I want. I have all of the free response questions that we did together in class or that I assigned. I think I have those at school. I do have, I want to say, yeah, everything got kind of messed up, obviously, with this interruption. But talk to me. Did we do the 2018 free response questions? Because I was looking at those, and I don't believe we ever did those. So let me bring this over here. Did we ever do this problem here, guys? This is from 2018. And when I'm thinking about, so, okay, I think I've said this before. I'm usually a pretty good guesser on what the free response questions are gonna look like, or what they're gonna entail. This year obviously is a completely different year. So when I'm thinking about, okay, what are the biggest concepts that they are going to possibly have on there that will test whether you know what's going on and give you a score and college credit and everything else for that. I'm thinking about obviously the concept that I've hit the hardest, which is where you are equals where you were plus how much you've changed, or that accumulation of change problem. And I also think a very common problem is like what I consider like this leaky bathtub problem, where you have the rate at which something is coming in and then the rate at which something's exiting. And so you have to take all that into account. So I think those are two of the main concepts. I think another main concept is using like a table. So a very common free response question is something like this, where they use a table and they ask you certain questions based on the table of values. And then another one is them giving you something graphically and having to answer questions that way. So these are the questions that we're going to focus on right now. So this comes from the 2018 AP Calc BC free response questions. And we're going to be focusing on problems 1, 3, and 4. 1, 3, and 4. Okay. And all I want to do right now to kind of finish up here, because we've already been on an hour, is I want to just discuss your approach for 1, 3, and 4. And then that's what I want you guys to work on until Thursday. Okay, and then we'll that's what we're going to discuss on Thursday, and then we're going to go from there. So let's look at number 1. It says people enter a line for whatever this is. It happens to be an escalator, which I've never really waited in line to get on an escalator before, but whatever. It's got to be a popular escalator. I did wait in line yesterday to get into Home Depot with my mask and gloves on. And then, anyway, so it says people enter a line for an escalator at a rate modeled by the function r given by r of t equals, and here it's piecewise where it says if the time is in between 0 and 300, and this is in seconds, then it's going to look like that. And when t is greater than 300, the rate at which people enter the line for the escalator is going to be 0. Okay. It says R of t is measured in people per second. T is measured in seconds. It says as people get on the escalator, they exit the line at a constant rate of 0.7 person per second. So people per second. Okay. So here's what we got going on. We have this line of people, right, to get on the escalator. They give us 2 rates. The rate at which that line is growing, meaning the rate at which people are entering that line, and the rate at which people are exiting that line because they're getting on the escalator. So the rate at which people get in line and the rate at which people exit the line. So one of those rates would make that line increase. The other rate makes that line decrease. This is a leaky bathtub problem. That's exactly what this is, right? The rate that water is entering the tub, the rate that the water is exiting the tub. If the rate that the water enters the tub is greater than the rate that the water exits the tub, then the water level will be rising. Well, for this, if the rate that people enter the line is greater than the rate that people exit the line, meaning get on the escalator, then that line will grow. But if the rate that people are entering the escalator line is less than the rate that they're exiting the line, getting on the escalator, then the line will decrease in value, right? Or the number of people in line will decrease. Anyway, and then they tell us there are 20 people in line at time t equals 0. So right when we start, there are 20 people in line waiting to get on the escalator. They're getting on the escalator and therefore exiting the line at 0.7 people per second. So that's like a negative in terms of the rate at which it's impacting the length of the line or the number of people in line. And then this up here is the rate at which people are entering the line, okay? So then they ask you a bunch of questions based on that. I think I've given you enough information to get you started on that. Anyway, let's move on to problem 3. Problem 3. They give us this graph, and this is the graph of G, okay? So, by the way, for the first one, you can use calculators. There are calculators for this one, but now for 3 and 4, there are no calculators. So for this is the graph of G. What they say is everything is linear except for from 3 to 6, it's this quadratic. G of x is equal, so the graph is parabolic, right? It says the graph of the continuous function G, the derivative of the function f is shown above. So G of x is the derivative of f. It then says the function G is piecewise linear from -5 to 3, and then from 3 to 6, it's this quadratic, or the graph is parabolic. If f of 1 is equal to 3, so they give us an initial value, what's f of -5? Well, again, this is something like, where you are is equal to where you were plus how much you've changed. f of -5 is equal to f of 1 plus the integral from 1 to -5 of g of x, because g of x is the rate at which f is changing, or the derivative of f. So anyway, they ask you that. So this is kind of like my area so far, explanation. But anyway, they ask some good questions for problem number 3. Okay, now let's look at number 4. Number 4, we have the height of a tree at time t is given by a twice differentiable function h. H is measured in meters and t is in years. Selected values of h are given in the table above. So you'll see that for the years, we have going from 2 to 3, from 3 to 5, from 5 to 7, and from 7 to 10. So the delta t, or the change of the time, is not the same, right? So that's a 1-year difference. It's a 2-year difference, a 2-year difference, a 3-year difference. So anyway, it says use the data in the table to estimate h prime of 6. So your 6 would be right here. We have the height at 5 and the height at 7. So what would h prime of 6 be approximately? So approximate that, estimate that based on the table of values. So that's like your, f of b minus f of a over b minus a, or in this case, h of 11, or sorry, I should say h of 7 minus h of 5 over 7 minus 5 is what that's going to look like. Anyway, and then it says, explain why there must be at least one time t in between 2 and 10 such that h prime of t is equal to 2. So you're going to have to explain that. Use a trapezoidal sum. And then they have you another. So anyway, so we have 3 questions that I'm going to give you guys from now until Thursday when we discuss these. You do have the scoring guidelines. They kind of go through everything and kind of explain what's going on for these problems that I want you to focus on for, once you do these problems on your own, you're going to go back and you're going to check your answers and see how many points you would have gotten on. Okay? So that's what I'm giving you from now until I see you again on Thursday. Thursday, we're going to have a class from, again, 10:30 to about 11:30 where we discuss that. But yeah, like I said, we are going to focus on free response questions. I think what I'm also going to do is go through many of the years free response questions that are already out there and give you guys a bunch of problems that I think are going to be similar to problems that I would expect you guys to see on the AP exam for this year. So that's what we got going on there. Okay, so that's what you got there. I also want to see your work from the practice exams that I just gave you over the spring break. So that's practice exams 3 and 4. I want to see that. So what I'm going to do is I'm going to put a, let's see. Yeah, I'm going to create an assignment for you guys so you can, similar to how you uploaded your homeworks from the last batch of homeworks, you're gonna upload. And in fact, what I'll do is this. I'm going to say, by this Friday, you have to upload exams 3 and 4 and your free response questions 1, 3, and 4 from the 2018 FRQs. So I'll create that assignment so you can upload pictures of your work for those assignments. Okay, so that's what we got going on. Any questions for me? You can type it in the chat or unmute yourself. By the way, if you just hold the space bar, if you're on a computer, if you hold the space bar and talk, then that unmutes. So you don't have to click unmute. You just hold the space bar. Any questions for me? All right. Cool, guys. I hope you're doing well. Let's meet again on Thursday, and we'll go through free response questions 1, 3, and 4 from 2018, and make sure you understand that. And then I'll give you more work that I want you guys to do. Obviously, you have all the free response questions from all the past exams that are there with the scoring guidelines. That's really what I'm going to focus on. There are some questions on the AP classroom that I'm going to give you guys, but I think it's smart for us to focus on the free response questions. In addition, I am going to do a few videos where I'm reteaching from limits all the way through, and I'm only going to do what you need. I will be reteaching. I think that's something that I'm going to start on Friday when I meet with you guys on Friday for my office hours that I'll have open. I'm just going to be starting my reteaching from limits, derivatives, everything else. But know that you guys know that on my website I do have calculus review here, and this kind of goes through everything, like the notes, the basic notes for everything all the way through. So that's a good point to kind of start. That's basically what I'm going to be doing, is reteaching by going through a lot of those notes. So that's what we got going on there. Yes, I am going to upload this. I'm still recording, so I'm going to upload this to YouTube, and I'll put that on my website as well. All right, guys. Have a great day, and get working on those free response questions. Thanks, guys.